All right, so the last thing is talking about how do we figure out if a function is an inverse of if functions are inverses of each other. Like you see right here, it says how to determine if functions are inverses of each other. So how can we tell that this function is the inverse of this function and actually have the mathematical algebraic proof behind it? Because a lot of times you can say, oh yeah, this is going to happen. Oh yeah, this is happening. But if you don't have the mathematical proof or the proof behind it, people are just like, whatever, you don't know what you're talking about. You got to have the proof. So we have to have that proof here. That's what we're getting ready to learn how to do to prove that they're inverse of each other. All right. So the first thing is if two functions f and f inverse, if they're really inverse functions of each other, that means that both of these are going to happen. F of f inverse of x equals f inverse of f of x. They all equal x. Anybody be like, oh, Mr. Hall, oh my gosh, whoa, that doesn't make sense. What in the world? What in the world? What's going on? So let me rewrite this so that it makes a little bit more sense. Remember when we talked about our composite functions? We did f of g of x and g of f of x. That's pretty much what we're doing here. We're saying f of quote unquote g of x, which is our f inverse, that has to equal x. And then the g of x, f inverse of f of x, has to equal x. So in other words, when you work these composite functions down, or when you work these out using like the composite functions here, your answer should always be equal to x. If they're not equal to x, if you put one function inside the other function and they do not equal x, that means that they are not inverses of each other. It is denied. It's wrong. They are not inverses. So again, when you do like put a function inside of another function, if they do not come back and simplify down to x, that means they are not inverses. F and f inverse are not inverses. And then, but with it, not only do you have to do it the one way, not only do you have to do it this first way to get x, but you have to do it the backwards way, and you still have to get x. If either one of these does not give you x, you can say these two functions are not inverses. But what's going to happen is 9 times out of 10, they're not going to say, oh, this is f and this is f inverse. What they're going to say is, okay, this is f, and they say this is h of x. Are they inverses of each other? And this, you will have to do the composite functions here to be able to tell if they're inverses. Again, if you do the composite functions of the two functions and get x, and then do it backwards of the composite functions and still get x, that means they're inverses of each other. That's what we're looking for here. So it's going to be a little bit of work, but we're going to do this. We're going to have it. It's going to work. Okay, so here, let's go ahead and go to an example. All right, so we have made it to the final example. So we just talked about like doing f inverse of x and getting the answer of x, and doing f inverse of f of x and getting x, and that means that they're inverses of each other. So that's what we have to do here. So example 3 says, given f of x equals 4x minus 9, first we need to find the inverse of x, and then we need to verify that f and f inverse are really inverses of each other. Are they really? Verify. All right. So first off, let's go start off with our regular function here. Our original function, original. And we're going to solve for y. Oh, sorry, we're going to find the inverse. So we're going to set this equal to y instead of f of x. And just like our last example here, we switch x and y. All right, switch x and y. And now we need to solve it out. All right, so let's go and solve it out. So we add 9 to both sides. Equals 4y. Okay, and then we just divide both sides by 4 so that way we can get y by itself. So we divide both sides by 4, we get x plus 9 divided by 4 equals y. Right? And so we're saying, okay, that is our inverse function. All right, cool. We get that part. We're good. All right, we understand that part. All right, we understand that. We got you, Mr. Hall. We got you. You good? You good right now? All right, so we're good on that. Now we have to do our actual verifying now. So we figured out what this is. Now we have to verify. Verify that these are both inverses of each other. Because if they're not inverses, then we don't have it. And 9 times out of 10, again, just to let you know, you will be given a function. You'll be given two functions. And you won't actually find the inverse and then actually verify. You'll actually be given two different functions. And then from there, they'll want you to actually do this next portion to verify that they are inverses. If either one of these do not work, that means pretty much that's it. So again, just a reminder, it's the same thing as saying f of g of x. So we're doing the same type of thing there. But what we're looking for right now is f of f inverse of x. So we're putting one function inside the other function. And our goal is hoping that it would equal x. That's our goal. Hopefully. Okay. So here, just like we did before, we write the outside function down first. And let me rewrite it down here, sorry. Let me rewrite it so I have space. So again, we write the outside function down first. So our outside function is 4x plus 9. Sorry, minus 9. 4x minus 9. Okay, so 4x minus 9. All right, now our inverse function is what we just found. I'm going to put that in black. That's our x plus 9 over 4. All right, so when we look at this portion here, whenever we see an x, we put that x plus 9 over 4 in that spot. Again, this is what we just did when we came to composite functions, so it's not brand new. We just learned this thing. It's all within 1 week, within a couple of days, actually. All right. So we substitute it in, and now we have to solve it out. So let's do some simplifications going on. So we know we're multiplying this fraction by 4. So it's a 4 on top, a 4 on the bottom. They can cancel each other out. All right. So here we're technically dealing with x plus 9 minus 9. Oh my goodness, this is going to be so hard. Oh, nutty, nutty, nutty. Nutty, nutty, nutty. So we have 9 and negative 9. And these are just with x. All right, so we're good. So far, we're good. We're good. So that means this first part is right. We're good on that part. Now, we have to make sure we come back and do the opposite. All right, and we're hoping that this way also gives us x. If this way does give us x, that means we verified that they're inverses. If this gives us something else other than x, we did something wrong with our inverse. We did something very wrong. Okay, so here, again, we're going to write the outside. Well, let's rewrite it here. All right, we're going to write the outside function down first. So here, the outside function is x plus 9 over 4. It's our outside function. All right. And so inside, again, like we did before, we're going to write down, and I don't know why I made that big because we don't need to write that big. We're going to do the actual f of x function, which is 4x minus 9 inside. All right, so whenever we see an x, we're going to put 4x minus 9 there. All right, so we simplify down now. We can go and drop the parentheses because really there's nothing being distributed or anything. So we can drop the parentheses. So really, we're dealing with 4x minus 9 plus 9 divided by 4. Okay. We get a negative 9 and a positive 9 that cancel out. Bam. See, this is going to be very simple, very easy. Get 4x over 4. Right? And then here we have a 4 on top, 4 on bottom. Those cancel out. And we're left with just x again. What? Say word. All right, so here, that works out too. We get x. So we got an x for the top, we got an x for the bottom. So because both of these work, and let's write this out. So since f of inverse of x equals f inverse of f of x, which equals x, all that there. Since this is happening, these two are inverses. All right, so you're going to do this every time when they ask you to verify. You're going to have to do both of them. You have to do this side and do that side, and they both have to equal x. If one of them doesn't equal x, so you get to this first part here and it doesn't equal x, you stop there and say, nope, it's not inverses, we're done. If you get this part and get x and get down here and it doesn't equal x, you stop there and say, nope, that does not equal x. And then you're done. So that's the whole part about this, is trying to verify, and then you're good. All right, so guys, that's it. That's all it is when we talk about inverse functions. All right, we made it through. Let's get it. Let's go.